I just wanted to have this video here to walk through some of the actions that you're going to take in the simulation so that you can either just follow along and complete the worksheet by watching the video, or just take a look at it if you have any trouble with the simulation itself, whether you can't access it or you're confused about what to do next. You can take a peek at this video and it will walk you through the steps. And what I'm going to do, since there are multiple sections to the assignment, and in some of those sections I'm going to be walking through detailed steps and actions that you'll take in the video, which you might want to do on your own. I'm going to put a little marker throughout the video for each of the different sections, so that if you want to jump from, say, part 1 to part 3, you'll be able to quickly scan through the video and find a little 5-second block that identifies here's the start of the next section, so you can go through the video and skip over the parts that you may want to do on your own and not watch me go through every single step of that video. For example, here is part 1. So the first thing we're going to do is we're going to open up the simulation, and it's here. So you see here we have this light over here. We have different types of light, electromagnetic radiation. Right? We have microwave, infrared, visible light, and ultraviolet light. Along the right hand side here we have several different molecules that we're going to examine. And then we have a couple of options for how quickly things take place in the main screen here. We also have this button here, which we're going to be using in just a moment, which brings up a different graphic that we'll be using. The first question here is ranking the electromagnetic radiation in terms of energy, wavelength, and frequency. We're going to rank each of these factors for each of these types of radiation. So when it says rank the radiation types, it's referring to these 4 things here: microwave, infrared, visible, and ultraviolet light. These are all different types of electromagnetic radiation. The first one, energy, it actually indicates right here with this arrow that as you go from left to right, they go from lowest to highest energy, and you can rank those on your sheet. The other two, wavelength and frequency, aren't obvious on the simulation, but if you click this box over here, this is where I was saying there's another graphic. This actually includes the different types. It also has some other things that aren't on here. So it's got microwave, infrared, this thin slice here, which is the visible light, the rainbow that we can see, and then ultraviolet. We don't go all the way up to X-ray and gamma ray. We don't go all the way down to radio waves, but we take a look at this middle selection here. So you can see it's got an arrow for wavelength and it's got an arrow for frequency and energy. You can use this diagram to rank the different types of EM radiation on wavelength and frequency, and actually you could use this to do the energy as well. So go ahead and do that. You can pause the video if you need to fill that out. The next step is where we're actually going to start to really use the simulation. So what we're going to do is, here's all of the molecules that we saw in the simulation on the right hand side in this box here. And what we're going to do is we're going to test each molecule with each type of radiation. Now if you want to do all of the molecules with microwave and then switch to infrared and then switch to visible light and so on, or if you want to do each molecule with all 4 types and then go to the next molecule, that's totally up to you. But what you're going to do is you're going to go back to the simulation, and let's start with microwave since that's the first column. We're going to start with carbon monoxide, which is the first molecule, and then we press this green button. Now when you press the green button, you're going to see little balls of light, which are really photons of energy, they're called, of these different types. So there's photons of microwave energy, photons of infrared, and so on. And sometimes nothing will happen because some of these molecules aren't affected by some or even all of these types of radiation. So you might sit there and see these photons coming out and nothing happens. That's fine. You would write no reaction or no response. But I do want to mention that it's not, whatever happens isn't necessarily going to happen with every single photon. So you might hit the microwave and you might see 1 or 2 photons come out, and then the third one does something. And then 1 or 2 might go by, and then the next one does something. And it's not a consistent pattern, but the point is you want to make sure you let several photons go by before you decide whether or not something's going to happen. So let's just take a look at this one, just as an example. Okay, and something happened there. And again, you can see it's not every photon, but some photons have an interaction. And then we would switch. Again, you can switch the molecules. We're still on microwave over here, but now we've changed to nitrogen. And then you can go through and select the different radiation types, and you can fill in this table. Okay, so what I'm going to do now is I'm going to go through and do all of the different combinations so that if you're having trouble with the simulation itself, you can just observe the video. But if you're using the simulation, you can now go off and just repeat each one of these steps for each one of these molecules and fill in this grid yourselves, and then you can sort of jump ahead to the next part of the video. Okay, so I'm going to basically stop talking and go through the steps of all the molecules with all the different types, and then we'll move on. Okay, I'm going to go back. I'm going to do carbon monoxide with microwave, and you can pause the video at any point to write stuff down. I'm going to switch radiation types. Switching to visible light. Switching to ultraviolet. So we've seen all 4 types of radiation with the carbon monoxide molecule. You can go back and watch any of them if you need to. I'm going to switch now back to microwave and move to nitrogen. Now I'm going to move to infrared. Moving to visible light. And ultraviolet light. Okay, going back to microwave and switching to oxygen. Switching to infrared. Switching to visible light. And ultraviolet. Okay, going to go back to microwave again. And carbon dioxide molecule. Now infrared. Visible light. Ultraviolet light. Go back to microwave and methane. Going to infrared. and visible light. Switching to ultraviolet. Back to microwave and water molecule. Now infrared. Now visible. And ultraviolet. Back to microwave. Nitrogen dioxide. Infrared. Visible. And ultraviolet. So I'm going to reset that so you can see that again. And as you're writing this, pay close attention to specifically what's happening in terms of the molecule itself. Okay, now I'm going to go back to microwave and ozone. Infrared. Visible light. And ultraviolet. Again, resetting so you can see specifically what's happening. Okay, so we've done all of the molecules with all the different types. You've seen a number of different reactions to different types of radiation. So now let's go back to the worksheet. You will have filled all this table in. The next question is about there were some molecules that weren't affected by any of the types of radiation that we looked at, and what that might mean in terms of gas in the atmosphere. So you can pause and fill that in. And then the next question here is going back and looking at the table and sort of making a summary. When it does have an effect, what is the effect? So what did you write down for microwaves for the molecules that it did affect? Did it do the same thing for all of the ones it affected? So make a note of that here. Likewise with infrared, what was the effect of the infrared light on those molecules that had an interaction? They didn't all have it. The same with visible light, and the same with ultraviolet. What was the common reaction for those molecules that did have a reaction to the different types? So fill that in. You can pause the video to write that down. Okay, so this next question, or actually really two questions, go together. So looking at the different types of radiation, and I'm sort of talking about both of these questions at the same time. There are certain characteristics of the molecules. If you go back and look, okay, we have carbon monoxide, nitrogen, oxygen, and so on. Some of these molecules have certain things in common. Okay, whether it has to do with the shape, some of them are in a straight line, Some of them are sort of angled like this. Some have different combinations of bonds, right? These little green lines represent bonds. So there's 2 bonds here, 1 here. There's 3 bonds here, 3 bonds here, and so on. So think about, and then also the other thing that might have some impact is that some of these molecules only have one type of atom, and some have multiple types, right? The different colors represent different elements. So water, we know, has oxygen and hydrogen. Methane has carbon and hydrogen. So there's different colors for the different elements. So try to take a look at the different molecules, and then going back to the reactions, see if you can figure out any common features, okay, such as the angle or the number of bonds or the number of elements or the types of the elements, and see if you can figure out a couple of characteristics that may or may not impact how they interact with different types of radiation. And then sort of building on that, in this table, write down which molecules were affected by microwave, which were affected by infrared, and so on, and then see if you can come up with a general rule that might be used to predict how another molecule would interact. So let's say, for example, that you notice that all of the ones that are this bent angle shape had an interaction with microwave radiation. And I'm not saying that's the case, but let's say that was true. That those 3, water, nitrogen dioxide, and ozone, all vibrated when they were hit with microwave radiation. Well, your rule might be bent molecules vibrate when exposed to microwave radiation. Okay, so something like that. That's just an example, and I don't think that that's actually what happened. But that's the idea. See if you can look at the molecules that interacted and what things they might have in common that would be used, so that if you saw another molecule and say, oh, this molecule is bent, just like the water molecule is. Therefore, based on what I've observed, it might vibrate when exposed to microwave radiation. That's what you're trying to come up with. Okay, and then the last one, or you're going to select one of these molecules. Sorry, here's the list. NH3, HCN, CH2O, and I'm not giving you the names for these, just reading off the symbols here, right? Pick one of these, go out and do a little bit of research. You can also use this other simulation, which is, it should work with most devices, but if it doesn't work, you can still find the information you need in other places. But see what these molecules might have in common with the molecules that you've just observed, and try to predict what it will do. So let's say you picked ammonia, NH3 is called ammonia. You'd put NH3, and it says assigned. I'm just going to let you select. So I think ammonia would vibrate when exposed to microwave radiation, spin around in infrared light, and have no reaction with visible or ultraviolet light. That's all you need to do. Use the information that you've gathered so far, do a little bit of looking to see what these molecules look like, find a diagram, and then predict based on what you know from your observations and all the diagrams and tables that you filled in here. What do you think that this molecule that you pick from this list will do? You can't test it, so it's just a hypothesis, because these molecules don't exist in the simulation that we're using. But use your deductive abilities and try to make a prediction. Based on what you've discovered so far, what will one, you only need to do this for one, pick one, what will that molecule do? Okay, and that's all you need to do for to finish up the worksheet, and then you can turn that in.